Good morning, students. As this welcomes you all. Now we are ready with the new chapter, that is current electricity. As in front of you all, I have written some of the points to be discussed in this chapter. Before starting the chapter, we should know why we are studying this chapter and what is the purpose of studying this chapter. Without knowing what is the purpose of the chapter, we do not take interest in this chapter. So, for that, we are just going to discuss the points what we are going to study in this chapter, and that are the points as I have written: electric current, flow of the electric charges, metallic conductor, drift velocity, mobility, the relation with the electric current, Ohm's law, resistance, VI characteristic, electrical energy and power, carbon resistance, carbon coding, series and parallel combination, temperature dependence of resistance, internal resistance of a cell, and difference between EMF and potential difference, combination of cell, series and parallel, Kirchhoff rule, Wheatstone bridge, meter bridge, potentiometer, comparison of EMF of primary cell, and to find the internal resistance of a given cell. But why we are going to study this? Just because to know what is current electricity. For that, we should know first what is electrostat. In electrostat, we have studied charges at rest. But here we are going to study charges in motion. Let us take the very first heading of the chapter, that is electric current. What do you mean by electric current? In the previous classes we have learned electric current is a flow of charge in a unit time. Or we can say that the rate of flow of charge, that is called electric current. But why we are going to study this topic? What is the use of this topic? So the basic use of this topic is in front of you all, that we are using any of the appliances that is being used, we are using that electric current, as we have to switch on the fan. Why the fan is working? The fan is working just because when the current is flowing through the wires to the fan. And like that, many of the appliances we are surrounded by in our daily life, that we are using electric current. How does it flow? The next topic comes. So that is the mechanism of electric current. We know that electric current flows in solid, liquid and gas in all the stages. In solid, it flows like free electrons. What are the charge carriers in that? That are the free electrons. In liquid, it flows like ions. You must have listened about the positive and negative ions. And in gaseous stage, it also flows like ion. So that we have to learn the mechanism of the flow of the electric current. Moving further, when we study about the electric current, we should know in a conductor is made up by large number of free electrons. And if it is made up by large number of free electrons, they do random motion in this. And when they do random motion in this, then they cancel the effect of one another while colliding one another. So that when the external source is given to that conductor, all the free electrons tend to move towards the positive end of the battery. And then they are tending to move with the positive end of the battery, the average velocity by which they are moving towards that positive end of the battery, that is called drift velocity. Why it is being used? If current is being flown in a conductor, then drift velocity is very necessary. It's there. Moving further, we know about the Ohm's law. If the physical condition remain unchanged, if the physical conditions like what? Temperature, pressure, etc. remains unchanged, then the current flow in a circuit is always directly proportional to the potential difference across that circuit. Moving further, there is a resistance. What is resistance? The obstacle or the hindrance offered by the circuit or the wire in the flow of the path of the current. Moving further, VI characteristic. What are the VI characteristic of that? This one is called voltage current characteristics, and these are for that you can say that ohmic and non-ohmic conductors. After that, we would study about the electrical energy and power. What is electrical energy and power? As we know that the energy required to conduct the electricity in the particular circuit, that is called electrical energy. And the rate of that particular energy can be said as power. Moving further, we have to study carbon resistor. What is carbon resistor and how it works? We'll study about this, and then we'll study about the series and parallel combination. As in 9th standard, 10th standard, we have studied about the series and parallel combination. The same we have to study here. then how it depends on temperature, whether it is directly proportional, inversely proportional, whatever we have to study in that. Then we have to study what is internal resistance of a cell. What is internal resistance of a cell? The hindrance offered by the electrolyte of the cell. That is called internal resistance of the cell. It is denoted by small r. We will study about this. And then we have to study about the EMF and potential difference. Let me discuss here what is EMF. EMF is what? Electromotive force. What is electromotive force? The total terminal potential across the circuit when no current is drawn from the circuit, that is called EMF of a cell. And when current is drawn from the cell, then this particular EMF can be called as what? Potential difference. As we are taking example, as we are just purchasing a cell from the shop, and we are not using that cell. We have not applied in torch and in whatever the material we are using, whatever the appliances we are using, we have not applied that. Then when it is not on, when the torch is not turned on, then that particular terminal potential is called EMF. But when we switch on the torch, then that particular terminal potential can be said as potential difference of that. So I hope you understand this. Then we have to study about the combination of the cell. As we have studied that resistor in series and parallel, the same way we have to study about combination of cell, series and parallel. How will we combine the cell? Then again the most important topic we will study, that is Kirchhoff rule. Kirchhoff rule is divided in two sectors, that is junction rule and loop rule. Junction rule is what? We will study about this, that all the current meeting at a junction, the algebraic sum of all the current is always equal to what? 0. Or we can say that all the current meeting at a junction is always equal to all the current leaving that junction. And next is loop rule. Loop rule is what? The algebraic sum of all the potential differences across the circuit or across the loop is always equal to 0. Or we can say that this one is you can say that the clockwise potential difference is always equal to that anti-clockwise potential. Then moving further, the application of this Kirchhoff rule, that is Wheatstone bridge and meter bridge. What is Wheatstone bridge? We will study about this. And what is meter bridge? We will study about this. And why meter bridge is called meter bridge? We will study about this also. And then the last topic, that is potentiometer. We will study about the principle of potentiometer and why it is used. It is used in the comparison of EMF of to a given primary cell and to the internal resistance to find the internal resistance of a given cell. So in this chapter, we will study about these points and we will discuss about these points. But the basic thing we have to keep in our mind, that is, we should know why we are studying this chapter. When we know the purpose of studying the chapter, we take interest in that particular chapter. So for this, we have to study one topic briefly, and we have to concentrate over each and every topic. I hope you are getting all these points, what we are going to discuss in this particular chapter. So in the next lecture, we'll discuss one by one every topic in every particular lectures. So as this, will see you again in the next lecture. I hope you are getting all those points what we have discussed here. Thank you.